For decades, the world of computer chips has been like a walled garden. Just a couple of massive companies held all the keys. But what if the blueprint for a processor was totally free? Free for anyone to use, to change, to build upon. Well, that's the radical idea behind RISC-V, and it's an open-source movement that is absolutely shaking the foundations of the entire semiconductor industry. So how did we get here? So on one side, you've got the old guard, the legacy players. Think Intel's x86, think ARM. Their blueprints are proprietary, totally closed off. And if you want to use them, you're going to be paying some pretty significant licensing fees. That whole world is controlled by just a handful of companies. And on the other side, you have RISC-V. It's an open standard, it's completely royalty-free, and it's being built by this global collaborative community. It is a fundamentally different way of thinking about who even gets to design a computer chip.
Okay, so I keep throwing this word blueprint around, but what does that actually mean when we're talking about a processor? Like, how does a piece of software tell a tiny piece of silicon what to do?
Well, it all comes down to something called the Instruction Set Architecture, or ISA. The easiest way to think about an ISA is like the dictionary or the official rulebook that the processor and the software both agree to use. It defines all the basic commands, stuff like add this number, load that data, or store this result, that the hardware can actually understand. I mean, every single program you use, from your OS to your browser, eventually gets translated down into this fundamental language.
Now, RISC-V didn't just pop up out of nowhere. It actually started way back in 2010 as a little summer research project at UC Berkeley. By 2014, it went public, and then a year later, the RISC-V Foundation was set up to kind of look after the standard. But then, in 2020, they made a really crucial move. The whole organization relocated to neutral Switzerland, and it became RISC-V International. And this was a very deliberate step to shield this open standard from the political influence of any one country.
And this, right here, was their mission from day one. The goal wasn't just to create yet another ISA, it was to make one that was completely, totally free and open. Free for students to learn with, free for academics to do research on, and free for any company anywhere in the world to build a real product with, all without paying a single dime in royalties. I mean, in an industry that's built on incredibly expensive intellectual property, this was just a revolutionary idea.
Okay, so how does it actually work in practice? The absolute genius of RISC-V is its modularity. Seriously, think of it like a big box of Legos. Every single RISC-V processor starts with the exact same simple mandatory base set of instructions. But from there, you can add all these optional extensions, just snapping on new capabilities as you need them. This right here is the foundation. It's the mandatory starting block that everyone has to use. It's called the base integer ISA, and it just has the absolute essential commands a computer needs to do basic work. Things like addition, logic, and controlling the flow of a program. It's literally the bare minimum you need to get up and running. And this is where that whole Lego idea just clicks into place. On top of that base I for integers, you just start snapping on the extensions you need. You can add M for multiplication, A for atomic operations if you have a multi-core system, and F and D for really complex math. It's such a brilliant design because it means you only include what you actually need, which keeps the final chip simple, efficient, and cheap. So this whole mix-and-match approach creates this really simple recipe for every chip. For instance, a super common setup for a general-purpose 64-bit computer is called RV64GC. Now, that G in the name is just shorthand for a standard pack of those common Lego blocks. So when you see a name like this, you're basically looking at a recipe that tells you exactly what that RISC-V chip is capable of.
All right, and this is where our story takes a huge turn. This open, collaborative, purely technical project has suddenly found itself right in the middle of a massive geopolitical chess match. In late 2023, members of the U.S. Congress voiced this exact concern. They were worried that the open nature of RISC-V could be used to get around strategic trade restrictions aimed at certain countries.
To really get what's going on here, we need a little bit of background. For the past few years, the U.S. has been trying to slow down China's progress in advanced AI. The main tool they've been using is restricting China's access to the most powerful AI chips and the super high-tech equipment you need to make them. But so far, these controls have really focused on the physical hardware, not the underlying design blueprints, like an ISA. So here's the bottom line. Because RISC-V is an open and royalty-free standard, it basically gives Chinese companies a pathway to develop their own advanced processors from the ground up. It lets them de-risk, to cut their dependence on proprietary foreign tech from companies like ARM or Intel, which, could be subject to current or even future restrictions.
And you can see how this creates a massive dilemma for U.S. policymakers, right? I mean, how do you deal with the powerful, globally developed open-source technology that could potentially weaken your own strategic economic policies? There are absolutely no easy answers, and two main schools of thought have started to form. So on one hand, you've got the argument for control. This path would involve trying to restrict U.S. companies and people from even participating in the development of RISC-V standards, hoping that that would slow down China's adoption. But then on the other hand, there's the case for competition. And this strategy argues that the U.S. should actually double down, that it should encourage its own companies to innovate and lead within the RISC-V world to guarantee American leadership in this new open standard.
But the thing is, trying to control an open standard like this, it's really, really hard. For one, RISC-V International is based in neutral Switzerland, which puts it pretty far outside of U.S. legal reach. Plus, if you push American firms out of the standards bodies, you could just be handing over leadership, letting China steer the future of the technology. It could also push American innovation and even companies overseas, and that could end up seriously hurting U.S. competitiveness.
So, the other strategy, it completely flips the script. Instead of trying to put the genie back in the bottle, it says the best way to deal with any potential risk is to simply win the race. This means supporting American companies so they become the dominant players in RISC-V design, software, and tools. And this isn't just about some high-tech rivalry. Whoever wins here could define the future of everything from your car to your smartphone, influencing the cost, the pace of innovation, and who controls the technology inside all of it.
So think about it. What kicked off as this cool academic project to build a better, freer computer architecture has now evolved into something so much bigger. It's become a test case for how we handle open collaboration in an age of intense technological competition. The future of RISC-V is going to tell us a whole lot about the future of global innovation itself.
And all of this really leaves us with one big lingering question. When an idea is open for everyone to see, and the collaboration is happening all over the globe, can any single country or company truly control its destiny? Or does its very openness make it unstoppable? It's something to think about. Thanks for watching.